Welcome to a journey that will change the way you see your DNA forever.
DIY CRISPR. Biohacking your genetic code begins now.
Welcome back, explorers of the genetic frontier. Today we're diving into the fascinating world of DIY CRISPR, where the boundaries between science and experimentation blur. But first, let's take a step back and revisit the groundbreaking concept that is CRISPR. In the realm of genetics, CRISPR isn't just another acronym. It stands for Clustered, Regularly Interspaced, Short, Palindromic Repeats. Quite a mouthful, isn't it? But what makes CRISPR truly remarkable is its ability to act as a molecular pair of genetic scissors, allowing scientists to precisely edit the DNA of living organisms. This isn't your average cut and paste operation. It's a genetic revolution. CRISPR has opened doors to a new era of possibilities in genetic engineering, enabling scientists to modify genes with unprecedented accuracy. From eradicating genetic diseases to enhancing agricultural crops, the applications are as vast as the genetic code itself. But why does this matter? Why should you be intrigued by the intricacies of CRISPR? Well, buckle up, because today we're not just exploring the science behind it. We're diving into a subculture of experimenters who have taken CRISPR out of the lab and into their own hands, the world of DIY CRISPR and biohacking. The DIY biohacking community is as diverse as the genetic material they aim to manipulate. From makeshift home laboratories to collaborative community spaces, these biohackers are rewriting the rules of genetic exploration. In this unconventional realm, you'll find students pushing the boundaries of their classroom knowledge, hobbyists driven by an insatiable curiosity, and innovators experimenting just for the thrill of discovery. Motivations within this community are as diverse as the individuals themselves. Some are on a quest for personal discovery, seeking to unravel the mysteries of their own genetic makeup. Others are driven by a desire to contribute to scientific progress outside the traditional confines of academia. Now, let's meet some of the faces behind the DIY biohacking movement. These are not your traditional scientists in pristine lab coats, but rather pioneers in unconventional spaces, each with a unique story to tell. Our first biohacker, who has turned their garage into a gene editing playground. Let's explore their journey into the world of DIY CRISPR and their motivations for taking genetic exploration into their own hands. First on our exploration is Josiah Zahner, a former NASA biochemist who has turned a corner of their apartment into an intimate genetic laboratory.
I think everybody's worried about the risks of genetic engineering and how it's going to hurt people, and nobody's worried about the risks of what's going to happen if we don't allow people to do genetic engineering.
Despite his background in biochemistry, Zahner found a passion for unlocking the secrets hidden within the strands of DNA. Zahner's motivation stems from a desire to democratize genetic exploration. He is on a personal quest to understand his own genetic makeup and in the process inspire others to embark on their scientific journeys. Now let's turn our attention to Elizabeth Parrish, the CEO of BioViva, a Seattle-based biotech company working to develop treatments to slow the aging process, with a penchant for pushing the boundaries of genetic experimentation. Parrish has undergone ongoing gene editing therapy to reverse the aging process and claims she has reversed her immune cells' biological age by 20 years.
Today's biotechnology is promising a better future for humankind. Using gene therapy, our cells can create the proteins they need to heal themselves, and this technology is becoming a reality.
How old does she look? Elizabeth is 52 years old. Does the gene therapy work? You decide. Parrish is not just exploring genetics for personal curiosity. She actively participates in collaborative projects, working with the aging community, contributing her skills to the collective pursuit of genetic knowledge. Our final spotlight falls on the scientists at Caltech. Here, individuals with varied backgrounds converge to share their passion for genetic exploration in a collaborative setting. In 2002, they created glow-in-the-dark mice by injecting mouse embryos with a virus that contained a jellyfish gene for green fluorescence. This was done to research the feasibility of DNA hacking to prevent disease. To date, scientists have created glowing cats, fish, pigs, and other animals. These scientists and the community lab are breaking down barriers, fostering an environment where the curious come together to unravel the complexities of genetic code. It's essential to navigate through the ethical and safety considerations that accompany this uncharted territory. First in our exploration is the ethical landscape. DIY CRISPR raises questions that extend far beyond the confines of a home laboratory. Let's peer into the ethical considerations that cast a shadow on the exciting world of genetic exploration. The very act of DIY gene editing opens Pandora's box of ethical concerns. As individuals become the architects of their genetic destinies, questions arise about the potential consequences, both intended and unintended. How can good and bad uses of these technologies be distinguished? Who decides which traits are normal and which constitute a disability or disorder? We must confront the responsibility that comes with wielding the power of genetic editing. This isn't just about experimenting with DNA. It's about understanding the profound impact these experiments can have on individuals, communities, and the environment. Simultaneously, let's shine a light on safety. A critical aspect often underestimated in the fervor of genetic exploration. Biohacking at home brings forth unique safety challenges that demand our attention. While the thrill of discovery propels biohackers forward, the importance of proper training and containment cannot be overstated. Safety isn't just a precaution, it's the foundation upon which responsible experimentation is built. DIY labs, whether in garages or community spaces, must adhere to stringent safety measures. From protecting the experimenter to preventing unintended environmental impact, safety protocols are the backbone of responsible biohacking, emphasizing the importance of education and responsible experimentation. DIY biohackers actively seek to minimize risks, ensuring that their foray into genetic exploration is guided by a commitment to safety and ethical considerations. Now that we've explored the motivations and challenges of the DIY biohacking community, let's dive into the heart of their endeavors, the projects, from scientific breakthroughs to artistic expressions. These DIY biohackers are redefining the possibilities of CRISPR gene editing. Our first glimpse takes us into the world of specific projects undertaken by DIY biohackers. What have they accomplished, both good and bad? Some projects are rooted in scientific curiosity, aiming to unlock the secrets of the genome and contribute to the understanding of all life itself. Others take a more artistic approach, using CRISPR as a tool for creative expression. DNA becomes the canvas and genes transform into brushstrokes, blurring the lines between science and art.
Life form is a unicellular organism with GFP bunny, a mammal that glows green, so a complex life form.
As we navigate this landscape of innovation, we encounter both successes and failures. Each attempt, whether triumphant or challenging, contributes to the collective knowledge of the DIY biohacking community. Let's celebrate the successes, the moments when DIY biohackers achieve their goals, whether it be modifying a specific gene, curing a genetic disease in a model organism, or developing a novel application of CRISPR technology. Almost 4 years ago, Victoria Gray became one of the first patients with a genetic disorder, and the first patient with sickle cell disease to get an experimental treatment that uses the revolutionary gene editing technique known as CRISPR. Today, all of Gray's symptoms are gone. In another recent clinical trial, the safety of utilizing CRISPR to combat cancer was demonstrated. In this study, researchers extracted immune cells from 3 cancer patients, utilized CRISPR to make genetic modifications, enhancing anti-tumor immunity. and then reintroduce the engineered cells into the patients with positive tolerance. While this particular treatment resulted in, at best, the stabilization of cancers, it lays the groundwork for future trials exploring CRISPR-engineered cancer immunotherapies. But in the pursuit of knowledge, there are also setbacks. Failures are an integral part of scientific exploration, teaching invaluable lessons and redirecting the courses of discovery. Aaron Trawick was the CEO of Ascendance Biomedical, a tiny controversial biotech startup on a mission to speed up the process of getting potentially life-saving treatments to patients. At a biohacker conference in Austin in early February, Trawick made himself a guinea pig, injecting his leg with a never-before-tested, non-FDA-approved, gene-altering herpes treatment made by the company. On April 29, 2018, Trawick was found dead in a sensory deprivation isolation tank, or float pod, at a float spa in Washington, D.C. He was 28 years old. Investigations are still being conducted. Biohackers, resolute in their quest for knowledge, view failures not as roadblocks but as stepping stones towards a better understanding of the genetic realm. They learn, adapt, and continue pushing the boundaries. As we stand on the precipice of genetic exploration, the future of DIY CRISPR and biohacking holds both promise and responsibility. The journeys we've embarked upon today is just the beginning. The DIY biohacking community, fueled by passion and curiosity, is poised to play a pivotal role in the evolution of genetic engineering. As technology advances and knowledge grows, the possibilities are limited only by our imagination. Yet with this boundless potential comes a call for critical thinking and responsible exploration. We encourage each biohacker, scientist, and curious mind to approach this frontier with a deep sense of ethical responsibility. The future is in our hands, quite literally, as we unlock the secrets of the genetic code. Let us do so with an unwavering commitment to responsible and ethical use of gene editing technologies. And your future is in your hands, whether you want to continue enjoying in-depth documentaries like this one. Hit the subscribe button for a vote of yes, and until next time.